So this video is going to be on graphing parabolas. And the general equation, or the nice graphing form or vertex form of a parabola, is y equal a, where a is your stretch, times the quantity x minus h squared, where this is going to do the left-right movement, and then plus k, which is going to be the up-down movement. Now you see here the vertex, which is our locator point for a parabola, is going to be h, which comes from this parenthesis. It's what makes this parenthesis 0, which would be h. And then plus k. If it's a plus k, it's going to be a positive k. If this is a minus k, it's going to be a negative. Now, the very first thing I'm going to do is I'm going to graph the parent equation. Y is equal to x squared. And when I'm graphing that, all that I'm really thinking about is squaring numbers. Okay, so let me just write some squares here. So 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25, and so forth. Now, when I square a negative number, what you need to remember is that a negative times a negative is equal to a positive number. So what does that mean? When I take a negative number and I square it, I am going to get a positive answer. So that means that when I am squaring a -1, a -2, a -3, and a -4, oops, and a -5, I'm going to get the same thing as when I square it as a positive. So this is going to be a 1, a 4, a 9, a 16, and a 25. So as long as you can square a number, you can graph a parabola. So I am going to graph, let me just get rid of this. I'm going to be graphing y is equal to x squared. And I am going to be graphing it by just thinking about starting at my 0, which would be my vertex for my x squared graph. And I'm going to go to 0, and 0 squared is 0. So I have a point at 0, 0. I'm going to kind of zoom in a little bit. Okay. I am going to go to 1. 1 squared is 1. So I'm at 1, 1. 2 squared is 4. So I have a point at 2, 4. 3 squared is 9. So I have a point at 3, 9. I'm going to go out 4. 4 squared is 16. So I have a point at 4, 16. So let me get up here to 16. Now remember that when I square a negative, I'm going to end up the same as the positive. So I'm going to have a symmetric graph here. So -1 squared is 1. -2 squared is 4. The quantity -3 squared is 9. The quantity -4 squared is 16. And then I am going to connect these points. Okay. So when I connect these points, it's going to be a U shape. It's going to be a curve. So I'm just going to do it kind of in a transparent one so we can see those points there. And that is going to be our basic parent graph, y equal x squared. Now, every other graph of x squared is based off of this parent graph. So if I was going to graph, let me keep that one there. I was going to graph, let's change my color here. Let's say I was going to graph y is equal to, let's see, I'll write it right here. Y is equal to the quantity x minus 5 squared, x minus 5 squared, minus 10, my vertex is going to be, because 5 makes that 0, 5, and then this is going to give me my y-coordinate negative 10. That's where my vertex is going to be. So I am going to come to five comma negative 10, put a point at 5 comma negative 10, and that's where my new parabola is going to be. So just to demonstrate to you, the only thing I've done is just physically I'm moving it every point to the right 5 and down 10. Let me just copy and paste this graph. So I would be taking this graph, okay? I'd be taking this graph and I'm moving this graph down to right here. And this is going to be the same graph, but located down here at 5 comma negative 10. Now, what I'm going to do is I'm going to plot those points, just a x squared focused right here. So I'm going to go to my vertex, and from my vertex, I'm going to go over 1. I'm not at 1, but I'm going 1 away, just like right here. This is 1 away. And when I'm 1 away from my vertex, I'm going to do 1 squared, which would be 1. So I'm going to do that here. So I'm going to go over 1. 1 squared is 1. So I'm going to go over 1 and up 1. And it's going to be the same on the other side. So from my vertex, I'm going to go out 2. And 2 squared is 4. 1, 2, 3, 4. So I'm going to have the same on the other side. From my vertex, I'm going to go over 1, 2, 3. 3 squared is 9, so I'm going to go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Same on the other side. And let's say I do one more. 1, 2, 3, 4. 4 squared is 16. So right now I'm down at negative 10. So if I move here, I've gone 10 above. And so I need to go 1, 2, 3, 4, 5, 6, which would be a total of 16 above my vertex. And then I can connect the points. So if I connect these points, here is my parabola. Again, it's the exact same parabola. It's just been moved. That's it. Now, just to show you that this really is the same graph, I'm going to substitute a value in for this equation here, okay? So let's say I wanted to double check, because I'm like, I don't know if that's really true. Let's say I want to double check that point. So when I put in a 7 into this equation here, this equation, when I put in a 7, I should be getting out a negative 6. So I'm going to put a 7 into that equation, okay? And so I'm going to get y is equal to the quantity 7 minus 5 squared minus 10. So that is going to be 2 squared minus 10. That's going to be 4 minus 10. So I get a negative 6. So when I put in a 7, I ended up with a negative 6. You see, I actually got that same point that I did without having to do a table or plug in my values into the equation, because I understand that I know how to graph x squared. And that x squared graph just got moved to this new vertex. Nothing has changed. It's still 1 squared is 1, still 2 squared is 4, it's still 3 squared is 9, 4 squared is 16, and so forth. Okay, so the next one we're going to do, we're going to have a stretch in front of it. And I'm actually going to make it a negative stretch. Okay. So for this one, let's say that our equation is y is equal to -2, that's our stretch, times the quantity, x minus 3 squared plus 20. So to identify my vertex, I'm going to be figuring out what makes that 0. So that is going to be a +3. And then this right here, this plus 20, that is going to tell me the y-coordinate of my vertex. So it's going to be 3, 20. Okay, 3, 20. And that's where I'm going to start my graph. So I'm going to go to, let me just get, I am going to go to 3, 20. Okay, so 3, 20 right up here. Okay. And let me just kind of zoom out a little bit. And so I'm still going to be thinking, go over 1, 1 squared is 1. From here, go over 2, 2 squared is 4. From this vertex, go over 3, 3 squared is 9. The difference is this stretch right here is telling me that I'm going to multiply what I get when I square my 1 and square my 2 and square my 3 by a -2. So that means my graph's going to actually be opening down. So I'm going to go over 1 from my vertex. 1 squared is 1, but I'm going to times that by my stretch of -2, and that means I'm going to go down 2. I'm going to go from my vertex out 2. 2 squared is 4. I'm going to times that by a -2, so I'm going to go -8. 1, 2, 3, 4, 5, 6, 7, 8. Same on the other side. It's making every value twice as high, or in this case, as low, in this case, because we're going down, or twice as far as the original parabola would have been from the vertex. So now I'm going to go 1, 2, 3. 3 squared is 9. I times 9 by -2, and I'm going to go down -18. So when I'm going down -18, that's actually going to put me down at 2 on this graph. Okay, so I went down -18. And let's just do another one more. If I went out 1, 2, 3, 4, 4 squared is 16. Times it by -2, I'd actually go down -32. So here, that's going to be 20. And then I need to go 12 more to get to be a 32. So I'm going to be down here and here. And let me kind of pull that back. And then I'm going to connect my values. I'm just going to change my color, sorry. Connect my values. And there's my parabola. Now, again, I could make a table. I could put values in. So let's say I was looking at this 5. 5, I'm up at 12, 5, 12. So if I was to put 5 into that equation, y is equal, hopefully I get out of 12. So y is equal to -2 times 5 minus 3, 5 minus 3 squared, plus 20. So I'm going to get a -3 times 2 squared, plus 20. We do that too. I'm going to get y is equal to -2 times 4 plus 20. I'm going to do a -2 times 4, which is a -8 plus 20. And I ended up with a 12. So you see, I put in a 5 into that equation, and I ended up with a 12. which is the same point I got just understanding how to graph x squared. 1 away, 1 squared is 1. 2 away, 2 squared is 4 from my vertex. And if you have a stretch after you square how far you're moving, 1 away, 2 away, 3 away, after you square that number, you times it by the stretch. Okay, so I'm going to do one more. This one, I'm going to have a maybe a fractional stretch. So let's say that for this one, I have y is equal to, let's do a positive 1/2 times the quantity x plus 2 squared plus 4. So my vertex, looking at this, is going to be -2 from this. So -2 from this, comma, and this is going to be a 4. So -2 comma 4. That's going to be my vertex. So let me start there at -2 comma 4. I'm going to zoom in a little bit. Okay, so -2 comma 4, that's my vertex. From this point, I'm going to be going out 1, out 2, out 3, and squaring those values, but I'm going to times it by the stretch after. So when I go out 1, 1 squared is 1, times it by a half, I'm going to go up a half. When I go out 2, 2 squared is 4. I'm going to times that 4 by a half, and I'm going to go up 1, 2. So I'm going to go out 1, 2, 3. Okay, notice I'm always staying at the height of the vertex. So I'm going to go out 1, 2, 3. 3 squared is 9. Half of 9 is 4.5. So I'm going to go up 1, 2, 3, 4, and a half. And same on the other side. I'm going to go out 1, 2, 3, 4. 4 squared is 16. Half of 16 is 8. So I'm going to go up 8 from here. 1, 2, 3, 4, 5, 6, 7, 8. And same on the other side. And let's say I went out 1, 2, 3, 4, 5. 5 squared is 25. And half of 25 is going to be 12.5. So this was a height of 8. So 9, 10, 11, 12, and a half. And there's my parabola. Hopefully that helps you out with graphing parabolas without having to make a graph. As long as you understand where the vertex is and how to graph 1 squared and or how to compute 1 squared and 2 squared and 3 squared. I'm going to make some more videos on the other graphs that we have been learning.